Thank you for joining the Gates Design Power webinar for belts. My name is Rob Michelson. I'm the product manager for Motion on belts, and I'll be running through some of the basics to start with and then hand it over to Rosie. The Gates Design Power is the latest engineering software tool, enabling users to accurately select a proper drive and also checking the health of the existing drive. Once downloaded, there are two publicly available applications in Design Power. One we've already gone through about 3 months ago called Design Flex Pro, and what we're going through today was the Design IQ. So Design IQ's a little bit for more complex drives involving multiple pulleys. The standard Design Flex Pro is 2 standard pulleys, belts, checking the health of the drive and tensions, etc. So Design IQ is multiple pulleys, so it's a little bit different to standard. And I suppose when we're on site, we also need to be getting a little bit more information. Standard information we normally gets kilowatts, speed, pulley sizes, belt sizes, and center distance if it's a new application. With Design IQ, we also need to know the position of all the pulleys so that we can paste it out and look at where all the dimensions are and get the tension values for each different section. So the presentation will take about 45 minutes. There's a Q&A button, so please use that. And at the end, we'll run through those questions and answers. But the best question will be in the running for a Motion prize pack. So put your thinking hats on that. So next slide, please. So yeah, we've gone through some of that. So next slide on that one. So this is the download slide. So this was also covered in the first session 3 months ago. For those of us who in Motion, we can't download that ourselves. We need to make sure that we get that done through IT. They'll have to get your VNC number and download it for you. But once you've got it, then you'll be good to go with both versions of Design Flex Pro and Design IQ. I think that's it. Next slide, and I'll pass it over to Rosie. So Rosie's our national product manager for power transmission, works for Gates. She'll run through the program today, how to download the software and navigation around Design IQ. So thank you very much. I'll see you later on. Thanks, Rosie.
Thank you, Rob. Good morning, everyone. My name is Rosie, and I work for Gates as a product manager. And then, yes, today we will cover the second of the program for Design IQ. We have training before 3 months ago for the Design Flex, but basically it's the same program which is combined the two options together. As Rob mentioned, so there is a free download program that you can log in on www.gates.com and then you can download it. If it is any problem, so you just can reach us, and then we can fix any problem you got for our support team. But you shouldn't have any problem to set up a new account and then start using the program. Yes, so as mentioned before, so next slide. So we cover the Design Flex, but today we will cover the second section, which is Design IQ. So Design Flex, just to do a summary of that, the Design Flex cover 2 drive points, and then Design IQ, you can do more complicated or multiple point designs. So where you can have a driven and driver pulley, and then you can incorporate idlers in, or how many idlers do you have in your drive. So that one is more complicated. So it gives you the options to work with multiple points, and then I'll take you through to the full application. So next slide. As you can see here, this is a snapshot of what we will do today. And then obviously I will jump to the program live, and then I will show you how to do. But for that, I just select an example for you just to drive today. So, and it will be a fan drive, which is, it will be 22 kilowatts and then 150 RPMs motor, which is working 10 hours. We will have idle, and then we also have a driven and driver pulley, and which is there will be 45 and 90 teeth, and then we will have a center distance of 330 millimeter. For this case, we will select our pulley change 8 millimeter pitch. In this case, we don't know, based on the input, we will know which lengths are suitable for that this arrangement. But I will show you in the program how it will work. So I'm gonna start sharing my computer. Okay, so when you open the program, so in the previous training, we just mentioned that you in the program you can work in a project, or you can work with a design. So this is the options you got in here. You also have on the top, you have options to save and then to use your program settings. But I can show you later how it works. So in this case, we're gonna start to a new design, which is in here, new project is you can select a new project and then work on different designs on that project. But for me, I will just, because it's only one, I will just do a new design. So for a new design, first things you need to set up is put it on a name. In this case, I just put it training for this time. Oh, I'll put design. Just for simplicity, I call design. And then after you call that, so you will have the option to select which one. So design flex is the one is a single point, and then design IQ is the one we will work today. So design IQ. So this is all another application which is more automotive, but in industrial. So we're gonna go with the design IQ. So you select your design IQ option, and then first things you have to see it, you have on your left option, so you can have your synchronized bell or V-bell selection, which is if you open the options, so you will have all the options you have for synchronized bell, and then if you open the options for V-bell, you will have the full range of the bells. So in that case, if you remember, we will use a pulley change 8 millimeter pitch, which is in that case, it will be a synchronized bell. Just close this one. So it will be a synchronized bell 8 millimeter pitch, which is this one. So you select the one. When you select it, you have that screen open. So in the bottom of the screen, you got all the options, and you see that you are working in metrics option. But if you want to change it, so you can change it in your tools with this unit scheme. So you have the option here to change it if you need to work in metrics or imperial, and then you select if you want to select as a default or in your current calculation. So in that case, I'm gonna leave it like that because it's a metrics, and normally Australia it works in metrics. So this is the first page that you got. So in this program, so you work in you have to work in your plane. So we have X and Y coordinates, and then I will go through to that auction. So first things is we got, on the example I got, is we have a driver pulley for 45 teeth, right? So this is my first pulley. So to add another pulley, and then you got all the auction here on the left side. So you got auction for add a pulley. This is an auction for a flip pulley, but I will use that one later and show you. You got an auction to delete a pulley if you don't need it, an auction undo, and then you also have auction here to zoom in and zoom out, which is really useful, depends on how complicated is your drive design. And then you also have the zoom fit, which is really nice as well, and I'll show you later how to use it. You got auction to pan, and then you have auction for pivots or slotted your either, so which is I'll show you in a minute. All right, so we will start for the first one. This is the first pulley, and then to add the second one, so you just press the button for add, and then you add the second one. So you have the second one, and then obviously we need to work in the same plane, right? So for your first pulley, which is number one, this one, so you have 0 millimeter X and 0 in Y. And then for the second one, which is this one here, is you have the central distance is on this example is 330. So you gave the 330. And then on your plan, Y plan is 0, which is the same. So in that case, you have just 2 points drive. If you see when the pulley is in green, it means that you are working on that one. So if you select this one here, so you can add, edit, or amend, calculations in this pulley. So to make more clear, you can also name the pulleys, what you're using. So for example, if you click on that, you can name that one. If you click on that, which is in green, you can name this one. In this case, I'm gonna click on the first one, and then you can call the motor, or you can call driver or driven. So I will call driver, this one, and you will see the name pop up in here in your screen. And then I will call the second one driven. Also, on the tops of the screen, you can select the direction of your drive design. This is the unclock or clockwise. And then also you got the option to for the selection of the lens belt, which is I'll show you in a minute. All right, so okay, so we need to modify the teeth of the pulley. So if I'm going to the driver pulley, we say that the pulley we're using is 45 teeth. And then for the driven pulley, we said it is 90 teeth. All right, so you see that's on the screen, it's out of the screen. So what you can do, you can use the button here like a zoom fit, and then you will get your a better vision from your drive design. If you want to put a smaller, you can just use the zoom in, and then it will be smaller, just to adjust your the sizes. So next one, it will be idler. So the idea for the IQ is included the idler, which is, again, you can use your option to add it. So this is the idler you included. So in this option is many options to change the direction or the position of the idler. So you got this button here, which is a flit, which you can have a back idler or inside. Or you also can have the option right click on your mouse, and then you can do the same thing. So you can do the same option. All right. So in that case, we're going to leave it like that. But for the option for the idler, so we can also, this one here is the third one. We're going to rename that one for idler. In that case, Okay, so we gonna call that one outside flat. Yeah, like that. And then after that, because we say the idler, we can put it as load idler. So we just put that option here. So this is the means that the belt, it will fit, depends on the movement of the idler. So if you go to the option on the top, so this is the default how it can be moved, depends on the length belt. But you also have the option here on the top, like you can give, the X and Y coordinates, depends on what is in your drive design. For this example, I'm gonna leave it as a default and then working for that. So, all right, so this is the first step. So we got, if we check here, so we got the direction of the driver, the direction of the driven, which is a central distance 330, and the idler, I just leave it as a default, what it is, but I will move, depends on the belt options I got. So next option now is select the belt, which is press that one here, the button here. And you will see the options that you got for the belt length. All the options in red, it means that one, it doesn't fit your drive design. So you also have an option here, which is a yellow one, and then the blank. So the yellow one, it could be a possibility, but it tells you that probably you will have a problem for install that drive using that belt. So in that case, the best option is go to the option which is in blank. So this is 8mm pitch, 12 12880 length. So you select that one, double click, and if you see your idle, it will be positioned based on that bed length, right? So we press OK, and in that case, is all done based on your parameter, input parameter. So next step in here, so if you see on the program, you got button here, belt type selector, so which is if you want to change it, so you go to that option here. If you want to continue with and you're happy with that, so you go to load entry. So in the load entry, just press OK. And then here you will have, and then you will check what you have. So you have auction conditions. So this is basically you use that auction if your condition is working on 100%, or if it is if you want to do example for 50% condition, so you can add a condition in there. But in that case, so I'm happy with the condition I got, so I will leave it like that. So what condition do we have for this drive design? Okay, so you have a different parameter here. You already have your name, convention names for your drive. And then also you can have the direction of your pulley. So if you see here, you can change it whatever if you like. If you're not, happy. In that case, it's very important, like if you position either, you need to position your idler based on not on the type side of the belt. So in that case, is it correct to position on the top? So that one is a clockwise, and then the idler is the base of the position. So if you see here, so we got different options to look at. So we have the RPN. So this is the input RPN. So the type, which is it will be the power units, which is you can also change it for power or torque if you whatever you use. You have the load size as well as an input. So in our case, because we selected at the beginning, we selected metrics, so you will have in kilowatts, but you can, if you have in horsepower, you can change it as well. So again, you can change your units in tools, and then it's changing in there. You have information for your test of your sprocket, which is 45 and 90, and then also approximately what it will be the OD for each one. So this is what you got until now. Another thing is the service factor, which is a help in here, which is it gives you a guidelines what do you need to use for service factor on VVLs. It depends on the condition of the hours, service hours, and the application you got. So as a default for VVLs is always started with 1.2, and then synchronized bell is started with 1.6. So in that case, we will leave it as a default one. But if you see here on the top, you got 8 hours, between 8 hours and 16, and we have the 16 and 24. In the example we pick up is for 10 hours, so it is going in here as a default, so it's 1.6. So we will work for 1.6. All right. Okay, what else do we got in here? Yeah, so you have the options. So you also have, if you're working on multiple designs, so you got on the right side, you have the multiple designs in here. So in that case, we are working on design 1, but if you have another design and come back to your other design is in here. And then you will have all the tab on the top on your right side. If you want to come back to the project, so you come back in here. Well, I'm not gonna come back to at this moment because I need to save it, but yeah, you can come back to the project on that one and rename it if you need it. But at the end of the program, you can rename it as well. Okay, so I'm going to start to input the information, the data we got from customer. So the customer said is 1750 RPN. And then we also have the load, which is 22.3 kilowatts. So we got driver and then the driven. So in this case, we assuming the full power for the motor is transferred to the driver. So we say it's 22.3. And then if you see the load transmit from the driven is transmit completely to the driver, right? So we have selected the 1.6 service factor. And then another thing that you can select it here is what is your driver. You already called that one driver, but it's important you have selected the correct one. So our pulley number 1 or the one we call driver is in here. All right, so what do you got on this one? So this is just a summary of what you got at the beginning. So you got all the tension methods. So you got force deflection. So you got tensionometer and then the force deflection, the force tension values. So and then you will have on the report the minimum and maximum, depends if it's a new bell or is it a used bell. What else do you got? So you got the pulleys, what you will need ratio, and then you will get also the width of the bell. So based on what we have provide here, so the program, it tell you that you will need a 21 width bell, which is in our case for pulley change is a standard one. But sometimes, for example, if the program tell you like is 19, so you will need 19 millimeter. So you can just, select the next size, available for us, which is 21. Or in that case, if, for example, if it tell you it's 50, so you can select 68 width, which is the standard one in pulley change. So you need to know what is the standard width for ours. So it doesn't mean that probably if it is anything customized, we can the bell, it can be cut on that width. But for this proposal, we just put the standard width. So in that case, we say 21. So 21 is right. So it's part of our standard range. And also you have here estimates average life for that design. So also on the span, you will have, information for the tension depends on the span. So you will have span 1, span 2, and 3. So span 1, if you see, is from the driver to the driven. So it's this span here. So span 2, it will be for the driven to the idler. So it will be this one here. And then the span 3, it will be the idler to the driven. So it will be that span here. So this is more related with the tension values that you will get in the report. Okay, so next step is the output. You press button output, and you will get the report. So on the report, is a couple of things that you can do on the report once you got that one. First things, you got the customer information, which is, it will be populating here. So for customer information, you just press that one, and then you can do your input. So I will put my name. You can put as much as you can, email, where that person is located, and then the state. And then you save it. And then if you see is all these auction is coming here, so you can just select the one you wanted and then apply the information, and then automatically it will pop up in here the information you just put it. So on the right side of the program, you tell you who is doing the program, and then the contact number and email address. In that case, I'm doing the calculation. So on the report itself, you have bell data, which is we're using a pulley change. The program will tell you that we need a 21 millimeter width, and then this is the length of the bell. Let me put a little bit soon on this. Okay, so on the left side, you have a layout of your drive, which is as we selected before. So this is what you got, and this is what you will do the calculation is done. So also you have a detail of where is the position of your pulleys, and then dimension of your pulleys, and then ratio for your pulleys, and then position for each one. So if you see here, driver is in a plan 00, and then the driven is a central distance 330, and then we got 45 groove and then 90 groove for the driven. And then for the idler is that we have an AOD black backside idler, which is it's 84. A good comment on this one, on our catalog in page 174, we got a specification of what is the minimum OD you need to use when you are using a specific bell. So in that case, because we're using an 8 millimeter pitch and then 21, so you need idlers, like it's the minimum OD, it has to be 80. So in that case, it's all right. So it's 84. So we're safe. So this is more to ensure that the bell doesn't stress if you have a smaller idler. If you put a smaller idler, the bell will be stressed, and then you will have a failure. So I encourage you to go to our catalog when you design, and then check that values before you start to doing your drive design. Because if it is an existing, probably you can use it and then see if your pulley selections are correct. But if it's a new one, so that one is a good guide to look at before. Okay, so options in here. So you got options this is the default report you got, but you also have the option. This is a really simple report, which doesn't give you just the layout and then just the information, input information, but you can do more complex this report. So If you go to Prim's options, so on the Prim options, you have all the extra information you can add it to your report. I suggest probably on the dynamic outputs, I would suggest to put details. If you want to have the shaft load summary, you can click on that. You can also tell information about minimum width, which is in that case, because it's 21, so it will give you the same value. Also, you have the option for hours if you want to precise, average hours live on this bell and rounded, or not to have anything. You have that option as well. And on the span for tension values, I would suggest to put all the spans, so you will have all that information in there. So you close in here and then close the report, I guess, and I think you will get the report details. It should be, yeah, so it should be more span report. Hang on, it doesn't include that. Let me try it again. Another thing to mention is we have had a lot of updates on the programs. So at this moment, and I forgot to mention at the beginning, so at this moment, the latest version is 9.949. So check on that if you get in that option. So if you're not on that version, so as a new program, obviously we have some problems like, bugs in the program. So they have been fixed. And then I probably the latest one is obviously the one is working better. But for get the new version, I suggest probably go and uninstall the old one and install the new one. So this is what we suggest. Let me go back. Let me refresh the button again. Okay, I'm not getting it, that one. I don't know what's happening, but I got, let's see here. Okay, it looks like it's doing the refresh. So it will take a little bit longer. Just thinking, just give me a sec. Okay. All right, so I got the report, the more complex report. So as mentioned, so this is the output data. So this is what we put at the beginning. So we select the dynamic data, which is it gives you, what you have, driver and driven pulley. So RPM, and then also the loads, and then the service factor. Sorry, let me put it bigger. You got some more information about the span tension and the shaft load. And then also in here, you will have the tension values depends on the span. Remember, I show you what's the span that it will be. So the span 1, the span 2, between 1 and 2, 2 and 3, and 3 and 1. So this is related with driven to driver, to the span for the either to the one of the driven or driver pulley. And then, yes, and then you got all the information about the different tensions values. So the first one is force deflection. So you will get the 3 values depends on the span. And then also you got, if you're using our tensionometer, so what do you need to use for the tensionometer? And then at the end, you will have the tension and force. So, and then again by span. So at the end, you will have also maximum load, shaft load as well as an information. And then if it is any information, any warning about the design, it will be pop up in here in that section here. So basically for this one here, so you just, if you want to save it, you just click, you can export as a PDF and then save it wherever you want. So you can call Rosie design and then save it as a PDF, and it will be saved as a PDF. And yes, so I think that's all. I will stop to share my computer. And then we can come back to the presentation. Next slide. Okay, so just to wrap up what we have done today, I show you in the first screen, I show you once you open the Design IQ program, what do you need? And obviously you need an input, and then what do you need for start your calculation values for the pulleys, driver, and driven. You will obviously need a center distance, and then if it's any idler or back idler or inside or outside idler, so you will need a confirmation for that as well. Also for the inputs, you will need the motor, so the kilowatts in RPM. Next slide. So we also see on the program the type of report you can get it, how you customize with the customer, so how you rename it, and then what do you get, and then how in details you want to present to the customer, so you can have that option as well in your in the buttons of the right side of the report. And then and obviously I would suggest for reports also include the tension values, because this is the most important thing. We also, on the calculation, we see that we can, change layouts and then move the pulleys clockwise or unclockwise. So, and then all of that, you can always come back to the program and then, edit it if you're not happy at the end of the report. Next slide. Okay, so as I mentioned as well, you can get detail for the report as much as you can. You can have the default report. It will give you only layouts. What is your coordinate X and Y? What is your pulley sizes? But if you want to include more, like a tension, nodes, noise, or maybe if you want to include, the dynamic data, you can have all of that in there. So as I said, it's the option for the print out of the report is on the right side, and then you can do your oscillation whatever you want to present to the customer. Next one. This is more like what is the benefit on that program. So you got inputs and output buttons that you can select it what you want. You get a report, and then also on the program you have the option to work for projects. And projects, as I said, if you have a project, you can work on different designs for the same customer, so you can call that project, or you can just use or do like a simple design for one design for a customer. Next one. So I think now while I'm doing the presentation, I couldn't see any question, but now is a moment that if you have any question, we can look at the Q&A chat, and then we will have, I think it's around I don't know how many minutes we got left to just do a question.
Yep, thank you, Rosie. So we have a question here from David. Is there a reason or preference for whether the idler goes inside or outside in a setup?
Well, as I mentioned before, the idler or the position of the idler will be depends how is the rotation of your belt drive. Remember, what we need to be sure is the idler is always positioned on the slack part of the belt, not on the tight part. So if you position on the tight part, you will have a failure on that.
Thank you. There's a question from Chris. Can this program be used to convert existing chain or belt drives over to pulley chain?
Well, what you need to have, obviously you will have a parameter. Yeah, you can do. You have a parameter for using your power, and then using basically power. What do you need on RPM? So you can modulate what it will be. The pulley change what you need. The deflex flex have the option to start the calculation based on the change, but in that case for Design IQ, what you need to have is your inputs, and then you can just do the calculation for the pulley change. So you can, in the pulley change, when you do conversion for change drive, so you have options to go for pulley change or GT4, and then it's normally on 8 or 40 millimeter pitch. So you can playing around between these two sizes and see based on that what you can offer. Depends on space that you got for your change drive, and then yes, and then you can play around around that. And then what is your limitations on as well center distance and all of that.
Great answer, thank you. We have a question here from Glenn. Can you put mutual belts on this program?
I will ask the questions. What was the belt again?
Can you put mutual belts on this program?
Okay, so I will ask the question. So we got plenty belts range on that, so I'll probably come back to you on this one. So if we add one belt on another, it's just have to be suggest to our support team, develop team. So if it is not in there, so we can ask the question, is it if the next plan for the new versions we include some of the belts that I mean is required.
Yep, we have a question here from Joshua. I have a customer that currently runs standard HP2 belts and consistently swaps them out due to wear and tear. Does this application have the ability to suggest a better setup to better suit the customer's needs?
Well, Joshua, what I recommend first is just run the calculation. I don't know if it's a multiple point or a single point, but run the calculation of what they have done, what they have currently have, and then check first simple things, so tension values and then alignment of the pull. So if the values are correct, probably I would suggest just to run a new calculation based on inputs, and then see if the suggestion of a program it will give you the same answer. So this is what I'll suggest to do.
The program also gives you the ability to look at the number of hours design life, I noticed. So therefore, if we know that the current belt's only lasting 500 hours, and they want to get 15,000 hours, well, then you could adjust the program and put in the appropriate belt to give it that extra life.
Yeah, thank you. Mick Grealish has asked, will the report also list the DBA values?
What does that mean, DBA values?
It's a noise.
Yes, yeah. So the DBA's values, yes, it will give you Design Flex, it will give you the noise value, but Design IQ doesn't have that option. So on the same Flex is only the one you have the selection that you got that one at the end of the report.
Tony has asked, can you easily select the next longer belt or shorter belt like the Design Flex feature and or next wider or next narrow belt selections?
In this case, when we select the belt, so you couldn't select the width, so the program will tell you what is the minimum width you need, and then you will select, it depends on the as I mentioned before, you will select depends on what is standard, but you cannot select, you know, the narrow one. So it will tell you what is the minimum you need for the drive design. So no, you don't have the option same that the Design Flex, but as long you are, you know, close to what they close. What I mean close is like to cover the width, the minimum width, so you will be fine. Obviously, you need to be very careful, not over design the width of the belt.
Perfect. And the last question that we have today is, will the report show rated load and ODR?
No in this one, no on the report.
We'll just get Rob Michelson to wrap up now.
Okay. Thank you all for attending. I hope you got a lot out of it. It's certainly haven't seen this style of program in any of our competitors, so it's got one ahead, and it's great for those more complex drives. It's not one that we're going to use every single day, but combined with the Design Flex Pro, I think it's a great package to be able to go in and solve any problem with a customer. I'd just like to thank Rosie for her presentation. A recording of this will also be sent out along with the Q&As to everyone at a later date. But if you have any more questions, contact Rosie, myself, or even your power transmission specialist in your region. So thanks again, and we'll see you next time.
Thank you, everyone.